All right, so we are looking at trigonometric equations in this video and solving them. And these are going to be pretty basic ones, so shouldn't be too terribly hard. So first thing that you need to do when you're doing this is you're going to go ahead and isolate your trig function. So like if I'm looking right here, my trig function would be the sine theta. So I need to get that all by itself. So the first thing I'm going to do is add 3 to both sides. When I do that, it cancels out over here, so that leaves me with 6 times sine theta, and that's equal to 3. So again, to get the trig function by itself, I'm going to go ahead and divide by 6 to both sides, and that leaves me with sine theta is equal to 3 over 6, which reduces down to 1/2. So at this point in time, in my opinion, it's easiest to just kind of go ahead and look at it on its surface right now and go ahead and go, this is just saying that it's wanting to know when is sine equal to, or what angle with theta would I need for sine to equal 1/2 in between 0 and 360 degrees. My answer has to fall within that range, and since it's given to me in degrees, I also need to answer that in degrees. So what I need to do is I need to look at my unit circle, and I need to find all times between 0 and 360 degrees when sine would equal 1/2. So that's going to happen. Let's think about that. If sine is going to be your y coordinate, sine is your y coordinate, and so it's got to be a positive 1/2. So let's think. So positive y coordinate means I'm going to have 1 here, and I'm also going to have 1 here. So I'm going to be in both quadrant 1 and quadrant 4. Or 4, wow. 2. And so I'm going to be doing either one of those quadrants right there. So what I've got to consider is right here in the first quadrant, when sine is equal to 1/2, is at 30 degrees. So I have theta is equal to 30 degrees. Then I have the one in my second quadrant, which is going to be 30 degrees above the x-axis because my reference angle here is 30 degrees. So if I go ahead and do 180 minus 30, I get 150 degrees. I can also see those values right here. I can see that sine is equal to 1/2 if I go and look at my unit circle, and I can see that sine is equal to 1/2 both right here as well as right here, and that is when it is equal to 30 degrees and 150 degrees. So I have both of those values right there. So that is one thing, okay? We can go ahead and solve number 2 right here. Oh, and right here, these are my only 2 solutions because it's got to be between 0 and 360 degrees. If it gave me some other different parameters, like if you look at number 2 here, it says between 0 and 180 degrees, or number 3 between 180 degrees and 360. So you get the point. This can change, so we have to pay attention to that. Also notice I do not have a restriction on sine for my value here, just like I will not have any restriction on cosine outside of, I shouldn't say no restriction. I do have a restriction on it. It's given to me as between 0 and 360. I don't have my inverse restrictions that are between negative 90 degrees and positive 90 degrees because this is not given to me as an inverse function. It's just a basic sine function, and sine is a periodic function, so I have an infinite amount of possible answers, but we have truncated that infinite amount of answers between 0 and 360 degrees. Okay, so over here in number 2, now we're going to have only potentially 2 answers at most, but honestly it's probably going to be less than that, but I have between 0 and 180 degrees that I'm looking for. So let's go ahead and solve and get my trig function all by itself. So that means that I'm going to subtract 5 from both sides. And 4 minus 5 is -1. So cosine theta is going to be equal to -1. Well, where on my unit circle does cosine equal -1? It equals -1 at 180 degrees if I go directly to the left from 0. So if I've got that as my answer, and that's my only answer, well, let's make sure that it falls within my restrictions, and sure enough, it does. It can be up to 180 degrees. So 180 degrees is my answer. Theta is equal to 180. So that's pretty basic, straightforward. Now I've got this one right here. All right, so again, I've got to get tangent by itself. So I'm going to take both divide by -2. Divide by -2 on both sides. So then I get tangent theta is equal to, and now here the 2's will cancel out, and it's just going to leave me with a -√3. So this is one that a lot of people tend to struggle with, is because tangent isn't just explicitly written on my unit circle unless we have learned those values and memorized those values. So really quick, if you don't have them or know them right off the bats, you should. Let's go ahead and say tangent right here. So if I'm right here at 0, tangent is 0. 0 divided by 1 is 0. If I come here, I do sine divided by cosine. I have 1/2 divided by the square root of 3 over 2, which becomes 1 over square root 3. And when you rationalize that, so as some teachers would say, when you scoot the root, you do square root 3 over 3. That's what you get. So if you do end up seeing tangent equals 1 over root 3, there's a hint right here that that's just not a rationalized form of that. If I do square root 2 over 2 divided by square root 2 over 2, well, what's anything divided by itself? 1. Then I come here, square root 3 over 2 divided by 1/2. The 2's are going to cancel out. That's just going to equal square root 3. And I come here, 1 divided by 0. Well, I can never divide by 0, so this is undefined. So that's going to kind of continue around my unit circle and match. The next question is whether or not it's going to be positive, negative, and so forth. But that's what I've got for my tangent values there. So let's come over here, and what did it say it needed to be? Negative square root 3. So, okay, these are all positive. So where is it negative? Well, it's positive square root 3 here, and that's when I have 1/2 is cosine and square root 3 is sine. So here, where I have negative 1/2 and positive square root 3 is sine, this is going to get me a negative square root 3 right here. I'm also going to get a negative square root 3 in my fourth quadrant, right here, negative square root 3 right here. So I'm looking at either 120 degrees or 300 degrees. So let's go up here, and what were my restrictions? Had to be 180 to 360. So that means that my answer is going to be 300 only. All right, so let's look at number 4 right here. Okay. Now this one's a little bit different. If you notice now on this one, I have cosine on either side, like it's there both times. So just like I would, and let me kind of just write it this way. So in case you ever kind of struggle, if you're looking at an equation and you're like, I don't know what in the world to do with this thing. How in the world do I solve this? This is crazy. One of the first things I would suggest if you ever do get into a position like that, which I promise you eventually will, you can get rid of the trig function just so you can kind of make it a little bit easier for yourself to understand what's happening. And I could look at this and just go 5x plus the square root of 2 is equal to 3x. You know, just get rid of the trig function and look at it with x's. That's a little bit more friendly for our eyes and the ways that we like to do things. And that might give you an idea of what to do. I don't necessarily anticipate that anybody's really necessarily going to struggle with this one, but like I said, you eventually will get to one that you will struggle with. So in this case, I'm going to go ahead and I'm going to get my cosines brought to the right side. So I'm going to subtract 5 times cosine theta, and I'm going to bring that over here to the right, and that's going to cancel out over here. Square root 2 is equal to -2 cosine theta. Okay, so now I've got to go ahead and get cosine by itself. So I'm going to divide both sides by -2. When I do that, that gets me that cosine of theta is equal to the negative square root of 2 over 2. Okay, so that's a pretty straightforward one. We probably recognize that one. That's usually on our 45s or pi over 4s. So let's think about where that's got to be. So if I'm looking at what my unit circle would have, it's got to be between 0 and 270 degrees. It's cosine, which is my x value. So my x value is going to be negative. And that happens in quadrants 2 and quadrants 3. So I'm going to have 1 over here and 1 over here. And remember, I said it's on my 45s. So over here, that's going to be 135 degrees. So theta is equal to 135 degrees. And right here in quadrant 3, it's 225 degrees. Okay, that's it. it wouldn't be any other answer if I added 360 or anything, or subtracted 360, because again, my restrictions are between 0 and 270 for this one. Okay, so this one's a bit different. This one has proven to be a bit of a challenge for some people, and most commonly it's just because we keep wanting to make some very common mistakes here on the left-hand side. I will show you two ways in which to approach this kind of problem, but don't fall for the trap. The common trap that would happen on something like this is somebody would see, oh, negative 10 divided by 2, they'd cancel out, and they say it's negative 5 minus square root 3, and that's equal to negative 5 plus sine theta. Except that's not right. And it's not right because over here, both of these terms are being divided by 2. The only time I can cancel out is if both of them have been divided by 2. So what I mean by that is, say for instance, actually, let me just do this. If I have negative 10 divided by 2 minus the square root of 3 divided by 2, when you're adding fractions and subtracting fractions, remember, once you get a common denominator, once you have them both underneath the same thing, you smush those things together and you just put that whole numerator over that single denominator. So you can see right now, once I've done that, I've split it up and I put it back together. And when I put it back together, it looks just like this. So you see both terms are divided by the 2. So I can't just outright get rid of it. I can reduce it on the left side, but it does still exist right here. So it didn't actually go away from underneath the square root 3. It is still there. So you can reduce it here. Like I said, you can go ahead and reduce it. It just needs to be still here underneath the negative square root 3. So once you've done that, then it kind of looks pretty straightforward. Now that you've gotten it, you have a negative 5 on either side. Well, if I add 5 to either side, well, that's gone. And now I just have that sine of theta is equal to negative square root 3 over 2. And that itself is pretty straightforward, between 0 and 360 degrees. So if I'm looking at my unit circle, sine is my y value. It's going to be negative over here in quadrant 3 and quadrant 4. Sine being negative square root 3 over 2 happens at 240 degrees and 300 degrees. So I have theta is equal to 240 degrees and 300 degrees. Okay, number 6. So right here with this one, again, get your cosine all to one side. And so then I'm going to go ahead and subtract by 2 cosine theta to both sides. And once I do that, over here I have 2 cosine theta left. And on the right, it's this negative square root 3. To get cosine by itself, we just divide by 2. And now I have cosine of theta is equal to negative square root 3 over 2. All right, now difference here is, if you notice my restrictions, is I have this. What is that weird R? What the heck is that? All real numbers. I wanted to know, and when I wrote this, my intention here was I wanted you to give me the infinite set required in order to give me the answer for every possible way that cosine theta will equal negative square root 3 over 2, all of them. And that kind of goes back to what we were doing yesterday. And so this right here, I've got theta. And so when theta is equal to negative square root 3 over 2 is cosine. So that's going to be negative over here on the left, over here in both of these quadrants. And that's going to be at 150 degrees and 210 degrees. So I'm going to write it as 150 degrees and 210 degrees plus 360 degrees K plus 360 degrees K. That gets me all of my answers in degrees. Now, my intention when I wrote this, I was looking at it and I was just trying to do all degrees on the front, and I was just thinking I wanted all answers in degrees. I should have specified that, but since I did not specify that, all answers should be provided in both degrees and radians. So then I also have to consider, okay, what is that in radians? So I have when cosine is equal to negative square root 3 over 2 is also at 5 pi over 6 plus 2 pi k and at 7 pi over 6 plus 2 pi k. So those are my other two answers that I needed to provide as well, because again, it says all real solutions right there, all real answers. All right, so on the back side here, we have radian measures. We know for sure it's radian measures because if I look at what it tells me for my domain for my theta, it says it's between 0 and 2 pi. That's not degrees, that's radians. And so right here, what I've got on here is I'd go ahead and if I was to solve this again, I'd go ahead and get all of my trig functions to one side because I've got to combine them together to isolate them. So I'd go ahead and add sine theta plus sine theta. And so that gets me 2 sine theta is equal to 2. And then I'd go ahead and get sine theta by itself by dividing both sides by 2. And that gets me sine of theta is equal to 1. So where does sine equal 1? Well, if sine is my y value and it's equaling 1, it's going straight up. It's right up here. Where is that? That is at pi over 2. So theta is equal to pi over 2, and that is my only solution that I have for this one. And that's just because sine only equals 1 in one place. All right. If I look at number 8, again, get the trig functions all to one side. So I'm going to subtract tangent theta to both sides. Okay, gets that all together. 3 minus 1 is going to get me 2 times tangent theta, and that's equal to 2. And then if I go ahead and get tangent by itself, I'm going to divide both sides by 2, and now I have tangent of theta is equal to 1. Again, tangent is not written explicitly on your unit circle. You should know that the way that I'm going to get 1 is if I'm dividing anything by itself, it equals 1. And so if I have tangent, it's positive. That means I'm taking sine and cosine, dividing them together. So it means that I need to have both x and y have the same sign in order for them to be for it to be a positive one. So not only do they need to be the same number, they also need to be the same sign. And when I say sign, I mean positive or negative, not trig function sign. Haha, I got jokes. Okay. So what we've got right here is where tangent would equal 1 would be at pi over 4, or what you guys would know as 45 degrees. However, if I go ahead and pay attention to my restrictions that I've got right here that it gives me, it says between pi over 2 and 3 pi over 2. Well, that's right here. That's going to be this left side, quadrants 2, quadrant 3. So my only answer here is going to be over here in quadrant 3 at 5 pi over 4. That is where sine is going, or not sine, tangent is going to be positive 1. Okay. If I look at number 9, again, get trig functions all to one side. So I'm going to subtract 3 sine theta. And I'm just going to kind of reiterate this because I keep having people making this mistake. This is 3 times sine. It's not 3 plus sine, 3 minus sine. I can't just subtract a singular sign and have a 3 over here. The only way that I could separate those is by division. Because it's 3 times sine. So this is 5 sine theta minus 3 sine theta. So it would be no different than 5x minus 3x. That gives me 2 sine theta. And that's equal to square root 3. And then I'd go ahead and divide both sides by 2. And that gets me sine of theta is equal to the square root of 3 over 2. And again, sine is y, so that's when it's positive, and I need y being positive up in quadrants 1 and quadrant 2. And if I look at my domain restrictions between 0 and 2 pi, so then that means that I only have these two right here that I'm listing. And sine is equal to 3 pi over 2 at pi over 3. So I have pi over 3, and it is also there at 2 pi over 3. Okay. All right, let's try this one. again, I've got to get trig functions all to one side. Told you, these are going to be pretty easy equations. We're going to get to a point where you're going to end up having to stop and think, probably. But honestly, it's my favorite part of math. Negative tangent theta minus 3 tangent theta is negative 4 tangent theta. Okay, and then to get tangent by itself, we would divide by negative 4. And negative 4 divided by negative 4 is positive 1. And that gets me 1 is equal to tangent of theta, or tangent theta is equal to 1. Feel like we just did that, except we didn't do it from 0 to pi. Instead, we did it from pi over 2 to 3 pi over 2. We've got both of these right here. And so it was just different restrictions on it, and it still works out to be part of the same answer. Or actually, no, it doesn't, because it's 0 to pi. So if it's 0, that is so not straight. I'm having an issue tonight on my sketchpad. It's probably because of the angle in which I'm writing. All right, 0 to pi would be from this side to this side. And again, tangent's going to be positive in quadrant 1 and quadrant 3 only. So right here is what I'm going to have over here, and that will be theta is equal to pi over 4 and exclusively pi over 4. Okay, this one right here. So again, we've got all real solutions on this one. So I will go ahead, and in this case, I'm going to add 2 sine theta to both sides. That way it makes it positive. So I have a negative 1, and that gets me a positive sine theta, and that's equal to negative 1/2. And then I can go ahead and isolate my trig function by adding 1 to both sides. And that gets me sine of theta is equal to, if I do negative 1 plus 1, I've got to get a common denominator. So I've got to put a 2 underneath there and multiply by 2 up here. Negative 1 plus 2 is going to get me 1, and I just keep the denominator. Alternatively, I hope that you know that negative 1/2 plus 1 is 1/2. But just in case not, because I know people do not like fractions. So then I have theta is equal to 1/2. So our sine is equal to 1/2. So now sine, again, it's my y value. It's going to be positive up here in quadrant 1 and quadrant 2. And so if I'm looking at that, when sine is equal to 1/2, that happens at pi over 6. It also happens at 5 pi over 6. And now, again, this is asking for all real solutions. So then I also have to ask myself, that means, just like I said on the front side, just because I intended this to be for radians, let's go ahead and be proper, and we also need to do our degrees. So that would also be 30 degrees as well as 150 degrees. And so here I would do plus 360 degrees K plus 360 degree K plus 2 pi K and plus 2 pi K. And that will get me all of my infinite possible answers in both degrees as well as radians. All right, last one right here. I just have a trig function over here, so I've just got to add 6 to both sides. Gets rid of that. And oh, wait, it gets rid of that. At least maybe 2 root 3 is equal to 2 times the tangent of theta. And then I would just divide by 2. And it cancels out on both sides. And that gets me that tangent of theta is equal to the square root of 3. And so then that's where you're like, oh, hey, square root of 3 for tangent. And, you know, again, I know that tangent's a harder one for people. And it's over here at pi over 3, when I would have the square root of 3 over 2 as sine and cosine as 1/2. And so again, this is going to happen twice though. So I'm going to have positive square root 3 up here as well as here. So my theta is going to equal to pi over 3 plus 2 pi K. as well as over here in this quadrant, that's going to be 4 pi over 3 plus 2 pi k. And then I just do also need to go ahead and state the degrees. And so in first quadrant, that's 60 degrees. And in my third quadrant, that's going to be 240 degrees. So I've got 60 degrees plus 180 degrees K. And I have 240 degrees plus. Oh, why did I write 180? Wow. Plus 360. Oh, sorry. Yep. No, I know why I said 300. I could have said 180. I could have, but that's not necessarily something that you need to worry about. But I will say you could do 180 because if you notice that these are straight across from each other. So if I was at 60 degrees, I could add 180 degrees and that gets me 240. And then I add another 180 degrees and it gets me right back. And then another 180. So you see, and so on and so forth. So I technically could do this one as plus 180 degrees, and I could also do just plus pi k as well. But these also work as well. All right, hopefully that makes sense. Let me know if you have questions.